This is going to be our review lesson number 2, but it's lesson 4 in the book we're following along with and all that stuff. So that's why the weird numbering. But speaking of weird numbering, we're going to talk about finding the nth term in a sequence. So the 5th term, 6th term, 100th term, 2,560th term, whatever else. Okay, so we're not going to spend a ton of time on this. We're going to do a couple of examples, and we're not going to spend a ton of time on this because we're going to pick this up again later in this course. We're going to put a couple of these pieces together, and so we're going to just kind of look at a couple of basic problem types and make sure we know how to solve those. That way, stuff will be easier later when we start talking about linear functions and we kind of find that we put this together. We'll visit this lesson again later, but we're going to just look at a couple examples and dive right in. I'm going to quit jabbering and get to explaining. So we're going to jump in with an example just like we do very often. We're going to find the 25th term in the sequence 4, 8, 12, 16. So now the brute force sort of way to solve this would be, okay, this is the first term, this is the second term, this is the third, this is the fourth. So let's see, we're doing 4, 8, 12, 16. That sounds like skip counting by 4, right? So the 5th term would be 20. The 6th term would be 24, etc., right? So that would be kind of the brute force. And we could just sit there and walk all the way down until this number turned into a 25, right? But that's going to take a long time, right? And so there are right now, there are two possibilities. We're going to put these two things together later. There's two possibilities for how to kind of form an equation out of this and do something with it. We're really hitting some pre-algebra, right? So we're either going to multiply a number or we're going to add a number. So I'm going to kind of list these. So I'm going to list these by position. So like position number, let me make that straight. Position number 1, position number 2, position number 3, and position number 4, right? And then, so I'm basically kind of cleaning up what I scratched out up here. I'm doing essentially the same thing. And then the other part of this, I'm going to put the term or the value of the term, right? So the first one is 4. In order to get, let me jot this down. The second one is 8. The third one is 12. And the next one is 16, right? Oops. I don't know why I wrote 12 twice. I just did. Happens to the best of us and the worst of us and everything in between. All right. In order to get from this number to this number is what we need to be thinking. How do we get there? Do we add it, or do we subtract it, or do we multiply it or divide it? And so to get from 1 to 4, you could add 3, or you could multiply times 4, right? So that would be how to get from 1 to 4, right? Because 1 plus 3 is 4, and 1 times 4 is 4. So we need to see where a pattern should work out. Right? So in order to get from 2 to 8, if we were adding, we would have to add 6. That doesn't match. That's not promising. But in order to get from 2 to 8, we would have to multiply by 4. That matches. That works out. Let's check it for the rest of our pattern. So if we were adding or subtracting these, we would have to add, again, this really doesn't match because we've got, what is it, 7, 8, 9 plus 9? But we multiply times 4, and we see that it works out the same way. So in order to get from the position or the term number in this particular problem to the number we're trying to get to at the bottom, our rule is, for this problem, is that that's a cool E. You don't know about all that. I don't know about it either. It's all right. The rule is we're going to multiply by 4. And that's how we're going to get from the position to the term. So if we want to get the 25th term, we're just going to take 25 and multiply that times 4. So the answer to this example 1 is going to be 100 because 25 times 4 is 100. So see, we found a rule in this case where we multiply. Let's look at another example. This one's also got a little bit of geometry, a little bit of head scratching and all those other things, right? So let's erase that, bring in some other things. So for our second example, this is the final example for this video. Again, we're going to revisit this topic in more depth later, but for now, these are kind of two options. You may have already guessed what this one's going to do, but let's see if we can figure it out. So we're, excuse me, we're going to describe how to find the number of diagonals that can be drawn from any one vertex in the polygon shown. Then find the number of diagonals from one vertex. So for this one, we need to figure out what some of these words mean. We may or may not know what some of these words mean, so let's kind of talk about this. So diagonals is where we connect one vertex to another vertex. Now, what are vertices or vertexes? A vertex in a polygon is a multi-sided figure. We're going to hit some of that in the future too and all those kind of things. A vertex of a polygon are the corners. So vertex essentially equals corner, right? So if you didn't know already, when you see the word vertex, you're looking for corners. So this shape over here has 3 vertices. This is a triangle. It has 3 sides, 3 vertices. This shape right here is a rectangle. It has 4 sides and 4 vertices. This one is a pentagon, 5 sides, 5 vertices, etc. Right? Makes sense? Easy peasy, lemon squeezy. So the number of diagonals that can be drawn. For a triangle, how many diagonals can we draw? Well, we can't draw any. Let me show you. Actually, let me show you the diagonals, how many diagonals we can draw from any one corner. So if we pick this corner, how many diagonals can we draw to get from here? If we draw along this, then we're drawing on an outside edge. So that's not a diagonal anymore. So diagonals have to be on the inside, right, for it to be a diagonal. So we can draw 1 diagonal. I already gave it away. I already gave the spoiler here that we can draw 0. Because if we go from this corner, this vertex, to this corner, we're not going through the middle. We have to go along the edge. And so that's 0, right? And to go from this one, let's see how many we can go from here. So if we go from this vertex, and I should note before I move on to the next one that if we were to, let me pick a different color. How about this pretty orange color? If we were to pick this vertex, we still could only draw 1 diagonal from there because these ones would be on the edges, and we don't want that, right? So we can still just draw 1 from any given vertex. How many can we draw on the pentagon? So this one, So this one, we can draw 1 to here, and we can draw another 1 to right there. Because if we draw here, that's on an edge, and we don't want that, right? And here it's on an edge, and we don't want that. So this one, we get 2. So we're going to kind of look at this the same way. We're going to build kind of the same sort of position and term. We can label these a little more descriptive in this one, and since it's not quite the same words, right? So we can do part of our little table we're going to kind of build as number of sides. Number of sides. And then for our other part, we can do diagonals, right? So if we have 3 sides in there, we can draw 0 diagonals, right? If we have 4 sides, then we can draw 1 diagonal. If we have 5 sides, we can draw 2 diagonals, right? So now let's see if we can walk through those and we can figure out what kind of rule we're going to build off of that. So if we're going to go from 3 to 0, we could subtract 3, right? 3 minus 3 minus 3 is 0, right? So we could subtract 3. Or we could multiply times 0, right? Because 3 times 0 is 0. All right, so that's that. If we're just looking at that one all by itself, that we could write that rule, right? So for this one, we could get from 4 to 1, we could subtract 3 again. I hope that's looking promising, isn't it? Or we could multiply times 1/4, and we don't really even know how to do that yet. I mean, you may, that part may be reviewed depending on your middle school curriculum and stuff. But that doesn't match. That doesn't work, right? Same thing here. We can subtract 3. I think we found our rule. What do you think? Or we could divide by, what would that be, like 2/5? Y'all are like, we've already figured out our rule, right? So our rule for this particular problem is to subtract 3. So to find how many diagonals we can do in a 10-sided polygon, we're going to do 10 minus 3. So 10 minus 3 is 7. So the answer to this example number 2 is 7. So for these type of problems, at this point, again, we're going to explore this deeper and kind of put these two types of rules together and some other stuff later in this course. But for now, you just got to figure out whether it's a multiplication or division rule or addition subtraction rule, and then do the thing. And that's all there is to this type of problem. If you're my student, thanks for watching the video. I'll see you in class. Do your homework, all the things. And if you're not one of my students, thanks for joining us. Whoever you are, thank you for liking, and give us a comment how else we can help you out. And a subscribe wouldn't hurt either. Thank you guys. Have a wonderful, wonderful day.